Okay, this video is going to go over 7.4e, which is using division to be able to graph polynomials. So what's going to happen is they're going to give you a polynomial like this, and you're going to have to divide it by the factor they give you, and then you're going to have to graph it. So let's go ahead and get started. The first thing I would do is I would be dividing this by this factor. So this one I'd probably run synthetic. I'd probably run synthetic for all of these because the factor they give you is just something nice and easy to divide by. So if you don't know how to do synthetic, go watch that video. I'm not going to reteach it. But basically, go ahead and run synthetic. If you get something other than 0 remainder, you messed up because they're giving you a factor, so it should divide in evenly. So if you got like 1 as your remainder, you messed up somewhere. But anyways, you end up with x squared plus 6x plus 5. All right? So you need to factor this further. And I'm not going to reteach you how to factor in this video either. So if you don't know how to factor, go watch that video. But basically, this would factor to be x plus 5, x plus 1. So my factored form is really x plus 5, x plus 1, and then everybody always forgets the first factor. Don't. It counts. It's part of your factored form. So now you can take this factored form and get your x-intercepts. And think about this polynomial. This is a degree 3 with a positive lead coefficient, so your arrows are going to be down, up. And this is basically all you need, all the information you need. These are all exponent 1s, so all these x-intercepts, they're all going to be straight throughs. So go put your x-intercepts on the graph, -5, -1, and 3. Drop your arrows, and then just cut straight through all these dots. That's what this one would look like. All right, so that's how I'm going to be approaching all of these problems. So look at this one now. Go ahead and run synthetic. All right, I got 0 remainder, so that's a good thing. So I'm left with x cubed minus 3x squared minus 9x plus 27. This factors further to be this. And then this guy, the x squared minus 9, is a difference of squares that would factor even further to x plus 3x minus 3. So my entire factored form, I have x plus 3. Now look at this. I had 2x minus 3's. So it's x minus 3 squared. And then don't forget your original factor that they gave you, x plus 1. Whenever you get to factored form here, your degree should match the degree of the original. So like this one would be degree 4, matches degree 4. So that's another way to kind of check yourself. All right, but anyways, it's degree 4. It's got a positive lead coefficient. So my arrows are up, up. At -3, I'm going to go straight through. At +3, I'm going to bounce. And at -1, I'm going to go straight through. So put these x-intercepts down. I'd probably even label the bounce, just so I know that one's going to be different. Drop your arrows. So the first guys are just straight through, and then I have to bounce off the one at 3, just like that. Okay, last one. Same thing. I'm going to start out by doing synthetic division. I got 0 remainder. So this, what's left is x squared minus 9, which factors further to be x plus 3x minus 3. So my factored form is x plus 3, x minus 3, and then the original one they gave me, this x plus 5. So I've got x-intercepts at -3, at +3, and at -5, and they're all straight throughs. So I go drop those on the graph. And this is a degree 3 with a positive lead coefficient, so my arrows are going to be down, up, so I would go ahead and drop those on the graph as well. And they're all straight through, so I'm just going to cut straight through every single one of these x-intercepts. And that's all there is to it. So make sure you do division. You could have done long division for that. It doesn't matter. Once you do division, you're going to want to factor whatever polynomial you get as the result. And then write it in fully factored form. Just don't forget the original factor they gave you. Everybody always forgets that one. A good way to check it is to check the degree of your fully factored form, so this degree, versus the degree of the original they gave you. And then it's just like graphing a normal polynomial. So hope this video helped.